We've been gaining experience. These exponential functions are kind of cool because you kind of know all the things. We're just going to keep gaining experience, trying some new things. And so you already know what an exponential function is. We're going to start with some really simple ones like here today for graphing. We know that this is an exponential function because the exponent, it's a variable, right? So we saw this with that getting paid, getting double, your penny doubled each day for that payment. We saw this with Fry's bank account. We've seen this lots of places. When that exponent is a variable, we get what's called an exponential function. So today we're looking at graphing them. So you've already seen graphs, right? Can anybody explain what the graphs look like, kind of just generally when you've seen them, Braden?
I know, like, it starts off strict and then it gets, then it, like, curves and doubles.
There's a curve in it, and things either become a lot or very little, kind of quick. So let's check out this. So right here, this is a domain. Nothing about the function says use this domain other than there's negatives and positives and they're relatively small numbers, right? It's a domain we're picking for reference points. Because how many points are on this function? In this function, how many points are there on there?
2.
Infinite. This thing's pumping out x, y values, right? So how many points are on that function? All the points. It goes forever. You can put anything in for x and it's going to give you a y, correct? All right. You guys all understand that's how functions work? How many points are on a line? Infinite. Okay, cool. So we've got this negative exponent then, right? If I slap that negative 3 up in for that x, I got 3 to the negative third. Negative exponent means reciprocal, right? In this case, it goes downstairs because it's in the numerator. But reciprocal. So 3 to the negative 3 is actually 1 over 3 cubed, which is 1/27. So what that means is in this function, when x is negative 3, y is 1/27. All right? Now there's a couple of ways to do this next thing. I'm going to just write it a little simpler. 3 to the negative 2, which is the same as 1 over 3 squared, which is 1/9. But also notice 1/9 is how much bigger than 1/27? 3 times bigger, right? And that's because I have a growth factor of 3 up here. So the next question I'm going to ask you is, because we built some pretty good functions yesterday. If my growth factor is 3, what's my initial amount in this function? So 3 is my growth factor. What's my initial value? So if my initial value is 3, it'd look like this. It's 1, right? So the reason we don't write 1 is because this is a little silly. Because it's just 3 to the x, right? So this is this. So just to make a connection to the functions you were writing last night. All right, so, but I know here, right, all my domains just increasing by 1. I've got a growth factor of 3. So what I like to do is I just start multiplying by 3. Boom, boom, times 3, times 3, times 3, times 3. And then I'm not messing around with all that substitution because I know my growth factor is 3. So it needs to go times 3, times 3, times 3, times 3. So I'm going to finish up writing my ordered pairs here. Ooh, when x is 0, y is 1, that point gets a special name. What is it? Yeah, the y-intercept. So now I got all these ordered pairs. Guess what I can do with an ordered pair? I can graph it. So negative 3. Make sure you're really careful. 1/27's right there, okay? It's kind of a joke. Kind of hard to. Just really close to 0 on those. Now negative 1 1/3, we can kind of do something. Then we got 0 1. There's my y-intercept again. Hello, how are you? 1 3. 2 9. And then what do you notice about 3/27? That's not fitting, right? They're all triple, right? Because my growth factor is 3. So then we're going to connect our dots. That's approaching infinity. That's approaching 0. Will that ever get to 0, though, do you think?
Nope.
No, because guess what? Divide by, so going this direction, we're dividing by 3, right? if you divide any positive number by 3, no matter how small, you still get a number, right? That's positive. So just keep that in mind as we start working on the bottom of this page. From our graph, we saw all those values increase. Is it a growth or decay function? Yeah, growth. All right. So what was the lowest that the y value could be?
0.
Never gets to 0, right? So it has to be greater than. So it can never equal 0 or be less than it. But 0 is our reference point, right? It approaches 0 as we move left.
So it would be like 1 over an infinite amount.
Yeah, you don't need. This is called an asymptote line. We don't need it until later. So the domain from our graph. Here's our graph again, right there. What if the domain's all possible x values? Who can explain to me what all the possible x values would be of this graph? All possible x values, yeah.
Would be, I guess, any multiple of 3.
Well, they're connected, right? So like anything on that whole line, there's infinite answers, right? That's not the answer, but there are infinite answers. Mas.
Less than 2.
Well, okay, so I like that you're pointing that point out here too. But there's point 327, I just can't see it, right? And there's point 4, what am I, times 360, 81. 481 is a point. Everything in between two. Braden.
Yeah. Okay.
What are you thinking, Braden?
X values would be infinite, but the Y values would be.
Well, so there's infinite x values, there's infinite y values, but what would the possible x values be? How far left does that go?
Infinite.
Forever left? Okay, how far to the right does it go? All the way to the right forever. So we would say that the domain is all real numbers. We can't say infinite because actually between like 0 and 1 is infinite values, right? So we don't just say there's infinite for both. But the range, so the range, what are the possible y values here? Yeah, Brunden.
Anything greater or equal, or no, anything just greater than 0.
Yeah, y needs to be greater than 0. 0 doesn't work, but even the little teeniest more does. You know what's interesting? Is you can't see that on the screen up there, but I can see it on mine. So y is greater than 0 is what I wrote there for my range. So let's take a look at this one. All right, I'm going to slap a -3 up in there for x. Let's change the color up. Ace, I pick on you a lot. What color would you like to use? All right, that was quick. So if I got 1/3 to the -3, that's actually 3 cubed, correct? So 3 cubed is 27. And remember, this domain is just a selected domain. It's all just reference points, okay? My personal favorite domain is usually -2, -1, 0, 1, 2. What just happened?
Yeah,
We figured that out. So 1/3 to the -2. Does everybody have 9 there? So you guys noticing what our growth factor is this time? It's a third. It's a third, right? So guess what I'm going to just start doing? Divide by 3, divide by 3, divide by 3, divide by 3, divide by 3. So I kind of just rock. If I didn't know that growth factor, I'm going by ones. I just start applying my growth factor over and over versus substituting and solving, substituting and solving. So I get these ordered pairs. -1, 3, 0, 1, 1, 1/3, 2, 1/9, and 3, 1/27. Everybody's favorite ordered pair. Okay, so I'm going to start plotting these. What did you guys notice about -327?
It's a negative.
Doesn't fit, but yeah. -2, 9, that fits. -1, 3. 0, 1. Ooh, there's that y-intercept again. Hello. 1, 1/2. Nope, just kidding. 1, 1/3. I know you can tell the difference there. Okay, so my line. Not a line, but when I connect it like this. There we go. Looking good. So what do you guys think? Left to right, getting bigger or smaller?
Smaller.
Smaller, so growth or decay?
Okay.
it's decaying. Don't have to worry about the asymptote line. Let's just look at domain and range. What's the domain? What are the possible x values?
Infinite. All real numbers.
All real numbers, yeah. Do you guys understand why we can't say infinite and be correct? Okay. Because, like, if I said between this point and this point, there's infinite numbers there. Right? So we have to say all real numbers. And then for your range,
Anything over 0.
y has to be greater than 0. 0 doesn't work, but anything above does. Braden.
What is an
Asymptote. So there's like these fake lines. There's like these fake lines where things approach 0. And there's another fake line where things approach infinity. And you'll worry about those more in advanced algebra. We don't need to worry about them. Yeah, but it's like an imaginary line where there's... do you keep hearing me use that language, approaching infinity or approaching 0? It deals with that. We don't need to worry about it yet. It's like an imaginary line. Yeah. Awesome.
Why is 1/3 so the negative third power 3?
That's a 3.
Oh,
3 cubed. It's not 3 times 9. It's 3 times 3 times 3. Which, I mean, it is 3 times 9. Yeah.
It would have to be square rooted of 1 instead of
Square root of what?
square instead of the exponent cube.
I mean, you could have an exponent in a root. Is that what you're saying? Because a square root's 1/2 power, so we wouldn't have a variable in
I
it.
don't mean like exactly square root.
You mean like
Yeah.
like a root like this? I'm not exactly sure what happened, but this would be 4th to the 1 over x power. Put in decimal, see what it looks like. I'm not sure what it looks like. It might look the same. Or inverse of it. Maybe I'm going to do that in a minute because now you got me interested. I don't know what it looks like off the top of my head, though. One other thing I want to show you. Like last night's homework, you had stuff like showing up like 20 times 1.5 to the x, let's say. Okay? If I'm going to substitute something in for my exponent, what do I have to compute first?
It's the 1.5.
Yeah, you have to compute the exponent first, right? Because order of operations. Some people will multiply here. Don't do that first because you can't. Another question I want to ask that's kind of interesting. So let's say you have this exponential function. It's times 3 times 3 times 3, right? What's the percent growth on that?
Whatever that.
What's the percent growth shown in here? 300%? 3%?
100%.
100% growth?
Oh no.
300? I'm hearing 100, 200, 300, 150. No, this one right here. So let's take a look.
That one?
If it's times 3, what percent change is no change, or what percent's no change? 100. So to get from 100% to 300%, that's 200% increase. So just be careful, like as that language gets thrown at you, times 3 is different than 300, because like a 300% increase, you'd have to actually multiply by 4. Because no change is 100%. 2 change is 2 chains cousin.
Oh, Lyndon? What?
I don't know. I just made a rap joke.
Lyndon with the 2 chains, let's go.
All right. I think that does it for us. I think we're ready to go on the homework, friends.